In part 1 of the lesson, we talked about generic classes, generic interfaces, how to subclass a generic class, and how to implement a generic interface. And now let's see how to declare generic methods. Generic methods are just methods that use their own type variables. And it's kind of similar to declaring a generic type. But the scope for the parameters, for the type variables, is limited to the method itself. If you use it anywhere else in the same class, it's out of scope. A generic method can be either static or non-static. So we have an example here, compare. It takes two parameters, P1, P2, and both of them are of type simple pair. Simple pair is a generic type that uses two type variables k and v. So to declare compare method as a generic method, we have to list the type variables before the return type boolean. So we have public static kv, and then boolean, compare simple pair p1, simple pair p2. The rest of the method looks like exactly the same as a regular method. The syntax for calling a generic method. The example we just had, that was a static method. So when you call a static method, you always start with the class name. In this case, it's util dot, and then integer string. We are specifying two type variables here, and then we say compare p1, p2. Or alternatively, we can omit the two type variables by simply saying util.compare q1, q2, because recent versions of Java can always infer type information, so there's no need to specify the type parameters before the method name. How to use generic methods to generalize behavior. So now we have, this is not a generic method. This is just a regular static method that counts the number of occurrences of targets from this string array. So every time there is a match, we increment count by 1. Otherwise, we skip it. So the question now is how to generalize it, how to make it work for all different types, not just for string type. So we can think of replacing string with a type variable t. Now let's leave it as an exercise. You can pause the video and spend a few minutes working out a solution, and then we want you to use the Stream API to have the functional style coding. Another generalization example, finding the max. Earlier we talked about this max method that takes a list of integers. Again, this is not generic because it only works for a list of integers. And now we want to generalize it. So we want it to work for arbitrary type t. So our first try looks like this. Public static, this is a generic method with type variable t, and then return type t, max1, taking a list of t. But it doesn't compile. It's not hard to understand that type t does not necessarily have a compare to method. So to make it work, we can let type t or class t implement a method comparable, because comparable forces its implementers to provide an implementation for compare to. So that way, we guarantee that type t always has a compare to method. This is how it looks like now. Public static t extends comparable t max with a parameter list of t. But comparable itself is generic. So we have to specify the type variable for comparable interface. So it's if you say comparable of type T, you are allowing two instances of T to be compared with each other. But if you say T extends comparable S, then what you do? So in the method T, you are overriding compare to method that takes an instance of type S. So you are actually comparing an instance of T with an instance of S, which doesn't make sense for this case. So we are going to have T extends comparable of T. Now we have this generic method. And this one does work for integer, for type, for class integer, for class double, for class float, character, and string, etc. But if we use it on the list of local dates, we get a problem. We see we have a list of dates with instances created and added before we call max, but max, this line of code doesn't compile. Why? To understand the problem, we need to see this diagram. So local date is a class that implements an interface called chrono local date. But this interface, chrono local date, is a sub-interface of comparable chrono local date. So basically, what we have here is a local date implements comparable chrono local date, not local date implements comparable local date. So this is inconsistent. This is inconsistent with the declaration of our generic method. So that's why it does not compile. So to fix this problem, we need to rely on something called wildcard. So what is a wildcard? It looks like this. So the question mark extends something, something being another type. Earlier we saw this example, manager being a subtype of employee, and so an array of manager is a subtype of an array of employee. But because of the incovariance, a list of manager is not a list of employee. So to make this work, we need to have a list of wildcard extends employee as the supertype of a list of manager. So with the use of the extends wildcard, we have this superclass subclass relationship. So with this in mind, let's see list 1 as a list of manager and list 2 as a list of employee. So obviously we cannot assign list 1 to variable list 2. The compiler doesn't like it for the reason we just talked about. But if we change the list of employee to a list of wildcard extends employee, and we are allowed to assign list 1 to variable list 2. And now another exercise. We're given 4 diagrams, and you should be able to tell which ones are correct and which ones are not. And then you should be able to explain why. Okay. So here are the solutions. A and B are incorrect, and C and D are correct. So take a look and explain why C and D are correct and why A and B are incorrect. Make sure you will be able to explain it during the final exam if you get a question like this. Some applications of the extends wildcard. So we know Java, there's a collection interface. Inside this collection interface, there's an add all method. So this add all method takes a collection of wildcard extensee. So imagine collection is a list of employee, like here, list 1. And then there is a list of manager as list 2. Then when we say list 1 dot add all list 2. So by saying that, we're saying list 1 as a list of employee, we can add a list of manager into list 1. Because add all method does allow a collection of the subtype of E. A collection of items that are of the subtype of E. In this case, that is the manager type. So this line does compile. Another one. Imagine we change the interface a little bit. So add all, instead of taking a collection of wildcard extends E, we take a collection of type E. So when we do this thing, list 1 dot add all bad list 2, if both of them are lists of employee, it works according to this API. But if we say list 1 is a list of employee and list 2 is a list of manager, and you cannot do list 1 dot add all bad list 2 because list 1 and list 2, they are different collection types. So you cannot use add all bad on these two lists. Another example, suppose we have a list of numbers, nums, and then we have a list of integer, we have a list of double, and then we say nums are add all integers. That works fine, right? We have seen that interface method add all. And then we say nums add all doubles. That also works. So we end up getting a list of numbers containing a mix of integers and doubles. Now let's see some of the limitations for using the extends wildcard. So imagine we have a list of integers, and then we can add 1, we can add 2 into the list. That's fine. But now, so we are assigning the list of integer to a variable of list of wildcard extends number, because this guy, list wildcard extends number, is a superclass of list of integer. So logically, it looks fine, right? So we're assigning an instance of a subtype to a variable of its supertype. But actually, when you try to compile the code, it doesn't compile. So when you say nums that add 3.14, the compiler complains. So why is that? So the problem is we are trying to add a double into a list of integers. This is not allowed. If we do allow this, and Java runtime environment will give you a runtime error, because in the list of integers, you're trying to add a double, so which should not be allowed. And there's another wildcard using the super keyword, so question mark super something. So in this case, we have this list of employee as a subtype of this list of wildcard super manager. So it's a little counterintuitive. How come, manager, something related to manager becomes the super type of a list of employee? But this is the way this wildcard works. So we have to learn how to get used to this. So what that means is similar to the extends keyword, or opposite. The wildcard stands for any type that is a supertype of the bounded type, okay, that comes after super keyword. So for limitations of the super wildcard, we saw earlier that it's difficult to add a list, add items into a list using extends keyword. So for wildcards using the super keyword, it's kind of hard to read, to get. The only guarantee you can get is you get an object from this collection, from this list. So let's see one example over here. So we have a list, wildcard super integer test, and then we say add 5, and then we print it. So this is fine. However, when you're trying to get something out from it, so we say integer val equals test.get0, we get a compiler error. Okay? Whatever you try to get, integer number or comparable, everything, every line gets a compiler error. But only when you say object val equals test.get0, it does compile.